In this tutorial, we will show you how to use a multi-impact synthesizer node to create some UI sound effects. This node is very powerful, but also very complicated. So let's start with a simple sound effect. If you look into UI folder, you will see an effect named UI Dialogue Typing. This node should be used together with a text typing effect. To use a multi-impact synthesizer node, you must have a multi-impact data. Let's create one. I'll name it Dialogue UI Beep. A multi-impact data file allows you to reference either an impact modal object or use a custom one. Since this is for UI, we will create a new modal object to control the frequency directly. Firstly, remember to enable manually set modal data. Then add a new item to our modal arrays. As mentioned in the document, each modal will have 3 parameters: amplitude, decay rate, and frequency. I will change the decay rate to 50, and increase the frequency to 880 Hz. Again, for UI, we don't need to use residual data. Now let's add an impact spawn variation. Disable residual synthesizer. For UI sounds, you should change the damping ratio to 1. A damping ratio of 1 means that impact strength won't affect decay rate. If you press the play button, you can preview the result. For our dialogue sound effect, its setup is enough. Let's create a new MetaSound graph. I will use the same name as my MID file. For UI sound, we can use mono output. Add a multi-impact synthesizer node and connect all the default pins. Promote this to graph variable. Then choose our multi-impact data. Let's try playing it with the default parameters. When running, this node will spawn multiple impact synthesizers at once. Since our spawn burst is 5 and our spawn chance is 100%, at time 0 it will create 5 impact synthesizers. By default, variation spawn type is random. So each impact spawn variation is randomly assigned to a synthesizer. We only have one here, so all synthesizers have the same parameters. And since we've disabled residual synthesizers, only modal synthesizers are spawned. Because spawn rate is 0, this node won't spawn any new synthesizers after time 0. But, as you can hear, not all synthesizers run at the same time. This is due to spawn start time range. A value of 0.2 second means that the true start time of each synthesizer will be randomly delayed by a maximum value of 0.2 second. So at time 0, 5 synthesizers are spawned. But one can start to create signals at 0.1 second. And another can start to create signals at 0.19 second. When the amplitude of all synthesizers has decayed to 0, this node will finish. For a dialogue sound effect, we need this node to continuously spawn new synthesizers until we stop it through either Blueprint or C++. So I will change the spawn rate to a positive number. I will also promote it to graph input so you can control the spawning speed of this effect. The minimum value should be 1 and the maximum value should be 20. A value of 10 means that this node will have 10 spawning intervals per second. Or, in other words, each 0.1 second, new synthesizers are spawned. The number of new synthesizers to be spawned is decided by spawn count. I will change it to 1 and spawn burst to 1 too. Spawn chance decay is 1, so our spawn chance will slowly decay to 0 over time. This is undesirable for our effect, so I set it to 0. Similarly, I want the impact strength to be constant, so I set both of these to 0 too. Let's try playing it again. Sound fine, but if I increase my spawn rate, some intervals have too many synthesizers. To avoid this, we must make sure spawn start time range is smaller than the spawning interval. So I will do it like this. Let's test this. Let's compare this with no start time randomization. Yeah, with randomization, it feels much more organic. A pretty simple setup, but very flexible. For example, you can shift the pitch down or up to represent different characters. You can change the spawn rate and spawn start time range to highlight the mood. Or use an LFO to modify the pitch to make it less monotonic. Around minus and plus 0.25 should be good enough. Also, notice the low CPU load. This is much better performance than playing a WAV file. You can find a more advanced version of this effect in UI Processing Graph. It sounds like this. Both the spawn rate and amplitude are increasing gradually, then decreasing gradually. The pitches are much more complicated. They are more chaotic, but still have a certain pattern. Let's view its multi-impact data. You can see that here we used remodels. The one with the highest energy has a high frequency. We also have more impact spawn variations. Each variation has a different pitch shift. We also add some small randomness to the amplitude. These are still pretty simple. In the graph, variation spawn type is set to ping pong. So the first synthesizer will use the first variation. The second synthesizer will use the second variation. And the fourth synthesizer will use the fourth variation. Then they will go backward. When they reach the first variation, they will go forward again. Hence the name ping pong. This makes the pitches have a certain pattern. And by using an LFO here, the pattern becomes more complicated. We use an attack decay envelope node here to control the spawn rate and amplitude over time. At the output, we use a delay node with feedback to add secondary beep sounds. This is a nice way to increase the number of impact sounds without spawning too many synthesizers at the same time. Delay nodes work very nicely with multi-impact synthesizers. In future tutorials, we will use it to enhance some effects. I hope you find this tutorial helpful, and I'll see you again on the next one.